our new space. We moved here about 2 months ago, so we're excited to have our event here tonight. And we're also excited to have some of our partners here to actually present some of the good integrations that we're doing with them. So I'm just going to do a quick introduction to some of them. Peter Duffy is here from Sumerian. He's going to be introducing our new insights capacity planning. We have Luis Horna from Solace, and also Raj and Jared are actually doing a presentation on Symphony. So I think, it's going to be just a quick, short presentation, and we can go after that and have drinks, have food after that, and socialize. So I'm going to pass it up to Steve.
Thanks, Joyce, and welcome to our new office. Traditionally, when we've been getting together with everybody, it's been under the guise of an event we call Tech Fest. Tech Fest originally was born about being more of a little bit of a meetup, and over the years, Tech Fest turned into something where we were only meeting with everybody once a year, and so we want to try to return it back to that. And with a meetup, we get something where we have a message that we're trying to deliver, or it's got a theme. So the theme for this one is integrations when it comes up on the screen. Integrations are obviously absolutely important for a company like ITRS. A framework. The framework is only as important as only as good as the integrations that we have. When I first started working with ITRS, the ideas, the integrations were all around the plugins. People saying, well, do you have a plugin for this? Do you have a plugin for that? What's your plan for plugins? And over the years, we've actually worked where the integrations now aren't just on the inbound side. Integrations are actually outbound as well, and we've got them at different levels of the software. So with these integrations, it's not just about integrating and saying, okay, we're going to send data over here, we're going to send data over there. It's about the responsibility we have when we're sending data. When we're sending data to somebody or receiving data from somebody, what are those responsibilities? How can we be transparent? How can we move the data through as fast as possible and most efficiently as possible? So when you're listening tonight and listening to the partners that we've brought in, that's the concept we want to get across, is that this isn't just about the integration, sending data. It's about that transparency. It's about the efficiently getting the data over to other applications. And we're going to continue that at ITRS. We published our roadmap on the website, and everything on there is directly or indirectly related to those to integrations. The single sign-on stuff that we're going to release at the end of the month, that is that's integrating with your directory systems, and that's because we don't need these administrators having to worry about permissions and all the stuff that they have to do today. MDM, we've been adding, for the market data folks out there, we've been adding, new adapters. I was just over in London last week working with the LSE. Our Thomson Reuters adapter was doing about half the story, but we needed one for ICE Data Services. So we partnered up with them, and ICE Data Services just, when they acquired the interactive data. So that was the interactive data feed. Now we were able to provide, the full story for them. They're monitoring about 82 exchanges over there. And so when we had the Reuters piece, it was only half the story. So now with the IDC adapter, we're now able to cover the whole story as well. On the middle tier, the integration that we have with Kafka now is absolutely important. Kafka is a rock solid piece of software, great APIs. And so being able to ship our data there and ship it there efficiently now provides an efficient way for our users to get their data out of Kafka as well. The last one is really on kind of our events and the data that we're sending out of Genos on our events. The stuff that we're triggering, the rules that we're triggering, that combined with our audit data, we owe it to the people consuming that data to be as efficient as possible. And so some of the standardizations that we're working on with that are really helping to make it so that the people consuming that data, whether it's a programmatic solution or or a UI, are able to consume it as efficiently as possible. So I hope you enjoy the discussions that we have tonight. In Meetup, in kind of true Meetup style, please come to me afterwards and let me know when we do another one. We need to come up with a theme for that one as well. So please come and give me your ideas. But I hope you enjoy. And first up is Mr. Peter Duffy from Sumerian.
Thank you, Steve. Cliff, do we have a clicker for the slides? And if not, I'll just do it by. Oh, sorry. Okay. All right, thank you guys. Yeah, I'm Peter Duffy. I'm CEO of a firm called Sumerian. We're based in Scotland. You probably guessed that from the accent. And incidentally, if anyone does need translating as I go through, just stop and we'll try and find someone who can do that for me. We've been on the go for about 15 years, very much focused on IT analytics. And I'm here tonight to talk about our partnership with ITRS to bring to you guys the power of capacity planning through ITRS Insights Capacity Planner. Just a bit about capacity planning for a second. Capacity planning is all about balancing risk and cost. The risk that you don't have enough capacity to process your trades to support your users versus the excess cost if you put in too much and you don't actually need it to process those trades. So that's really what we're looking at capacity planning. And a couple of interesting statistics to throw out there. When we look at the actual impacts to business services and applications, the outages or the degradations that happen, just short of 1 in 3 of those tend to have a root cause that goes back to capacity management. And on the flip side, worldwide, about $30 billion is overspent annually on excess compute capacity. Servers sitting in data centres not actually doing anything. So that's a massive amount of money when we're still getting these problems with capacity outages. A whole bunch of reasons for that that are called out along the bottom there. It's a difficult thing to do. You have to predict the future. It's complex situations. There's constant change. You need specialist skills. All of those things. We're making all of those go away with ITRS Insights Capacity Planner. So Insights Capacity Planner is, capacity planning as a service. It's based around a core software as a service solution. So you can get rapid time to value, pulling data from Genos and any other tools you have, getting that data in, building up a long-term picture of your environment so that you understand what resource utilization looks like over a long period of time, bringing in application and infrastructure information, using big data techniques to store and manage that data, compress that data, deal with it so that you don't have to, because it's again software as a service solution. Applying predictive analytics to that data, so machine learning algorithms that discover the trends and the patterns in that data and tell you about problems before they happen so that you can get on the front foot, start being proactive instead of firefighting outages. And finally, has best-in-class scenario modelling capability, and I'll show you some of this later on. We're only going to do 5 minutes in slides, then we'll jump into a demo where you can actually model out planned changes to your environment. So if you have to do 3 times your trades in a particular day, then you can model out to see if you have enough infrastructure to do that. If you have to process double payments in 2 hours, then again you can model that out. You can get the evidence to say, yes, I'm able to deal with that scenario, or no, I can't, and I have to invest in these particular areas to get additional resources to make that actually happen. I like to think of capacity planning as having a sort of a maturity continuum from the left to the right here. The basic hygiene is reporting. Can you report on what you're actually using and how that's being used by various parts of the business? Then you want to move on quickly beyond that to say, okay, can I use that data to actually optimize my environment, to actually refine my environment, to reclaim resources from areas where they're not required and reallocate them to areas where they could be better utilized? And you can move on from that to say, can we then predict, as I mentioned earlier, those problems that are going to come and get me tomorrow, next week, next month, so that I can avoid them. And then finally, you can move up to the top of that maturity piece where you actually are planning out all of your changes and understand the capacity impacts of those in advance. How it works is pretty simple. You have one new piece that sits in your environment. That's the Insights Data Collector. It's going to connect to your Genos gateways and other tools. For example, if you've got a virtualized environment, you want to augment it with information from vCenter, that can be pulled from there as well. That data gets collected every night. Now again, Genos is very much focused, I'm sure all you guys here are very much focused with Genos on real-time, understanding what's happening right here, right now. Capacity planning, in contrast, is not a real-time endeavour. You don't want to make your capacity decisions based on what's happening right here, right now. You want to make them based on a reasoned analysis of what's happened for the last 3, 6, 9, however many months, and a statistical view of what that looks like. So we don't connect to the data in real time, we bring it back every night, build up a rolling baseline of your environment, and then you can use that to make those decisions. We are very much focused on bringing this connecting with Genos, and one of the key reasons here is that very often you see a split in capacity planning where some people look purely at infrastructure, some people are much more interested in their applications, and really what you have to do is be able to join the two together. And Genos provides us that rich seam of data where we can bring in both the infrastructure and the application data. I'm going to show you in a minute some of the really cool things that you can do when you have those things together. And then just last slide. I mentioned that capacity planning is about risk and cost. Just some examples of where customers have had value delivered from using Capacity Planner. One of the world's largest global banks worldwide, they are avoiding 300 outages per year in some of their most critical applications just by having those predictions that tell them storage, temporary databases, networks, memory are going to fall over if you don't take action in advance. Life sciences company out in California, they were doing a data center transformation. If they hadn't been using Capacity Planner, they would have moved a like-for-like set of resources from one data center to another. By using Capacity Planner, by optimizing that, they were able to reduce that by 24%, so 1 in 4 cost reduction on that data transformation. So others that are here as well. And if you want to talk about any of them, just come and grab us afterwards. Right now I'm going to ask for my glamorous assistant Scott to come up and drive so that we can get through the demo. I tried doing this earlier with one hand in the mic and one hand in the mouse, and it just absolutely wasn't working. Okay, let's just jump in. We're going to look a little bit about sort of the two aspects of capacity planning, sort of infrastructure and then application, and talk about how we can join those together. This is an infrastructure view of an environment. So we're pulling data, in this case, from something like Genos, vCenter, SCOM, whatever those tools actually are. And we're then using that to say, well, what does my infrastructure actually look like? This is a view of a baseline. And again, we are focused on a long period of time for capacity planning. So you'll see the little pop out in the top left there saying that that's data from March through to June of this year. So we've got 3 months worth of data on which to start making our capacity decisions. What we're seeing in this visualization here that we call a sunburst, it's think of it as a hierarchy radiating out from the centre. We've got 3 data centres. We've got sort of Edinburgh, London, Glasgow. Within each data centre we have a number of clusters. Some of those clusters might be of, in this case, ESX hosts, and we have VMs around the outside of them. Some of those clusters in the C5 case there are physical hosts. And what we're really interested in for capacity planning at this infrastructure view is what resources do I have deployed in various environments, how much usage am I making of them, and what does that mean for how I can grow into that environment. So if I take any one of these hosts, for example, I can sort of drill into a headroom view of that, and I can see that I've got so much memory deployed in here, and I'm using this small amount of it here. I've got so much CPU deployed, and that usage piece again is that analysis of the last 3 months. So it's not this is what's happening right now, it's 95% of the time over the last 3 months. This is how you are consuming these resources. So you start to get that picture of what your infrastructure actually looks like. Now that's interesting. That's interesting from an infrastructure perspective, and that view aggregates up so I can have a look and see what's happening in my London data centre. I can see what my total aggregate resources are that are deployed in terms of compute, memory, disk, storage, how I'm using those, how much I have left, and so on. And I can even go and get some recommendations. So I might want to say, in my London data centre, how much resource could I potentially reclaim? So I can jump into what we call a demand profile here. And here I can see a number of servers that are being strapped for CPU resource. So they're sitting at 99, 95, 70%. And again, that's not just right now. That's over the course of the last 3 months. 95% of the time they've been sitting at that level. So those are some servers that need more resource allocated to them. On the flip side, I also have a number of servers where utilization is much, much lower. So here we've got a number where, over the last 3 months, only 5% of the time has it gone above 0.7% utilization. So some real opportunities there for reclaiming some resource and allocating it out to the areas that need it. So that's an interesting infrastructure view, but what I'd like to focus much more, because we can get much richer data from Genos, is more of an application view of the world. So let's look at a different sunburst. Here we have an application, it's actually a mobile banking application for one of our customers. It's got 4 tiers to it. There's a JVM area, a web server, app server, connectivity server. Now when I'm looking at an application, I'm still interested in the underlying infrastructure resources, but I'm also interested more in that application data, things like, how many transactions are happening, what's the response time of them, again, for that period of time. So we can jump in here to what we call our metrics explorer and start to view some of that application level data. And again, this can be coming from Genos. Genos focused on the real-time piece of it, and then we're bringing it back in and building it up to focus on that sort of longer-term analysis of it. So here I've got a picture of the number of transactions that are being driven through my mobile banking application. I can see there's a sort of weekly and weekend piece here. So I can get a view of the total number. This is the aggregate number of transactions. I might want to drill into those and see what does the response time look for some of those transactions over that same time period. So I can drill down and have a look at that piece there. And again, here I might have response times, for example, for some of my logins or some of my security challenges, or for if I'm checking my balance. And again, I can get a picture of what that looks like over a long period of time. You can see that I've got some interesting spikes coming up here. Now, presumably, if I own this application, I've got some limit that I want to set on that. I don't want my login to take more than 3 seconds. Don't want my balance check to take more than 3 seconds, things like that. And perhaps there's a relationship between the volume of transactions, number of users, and that response time. And we can actually discover that. So if we jump over to the next piece, here we've got an example again. This is our transactions per minute being driven through the banking application itself. Down here we've got the response time of one of those types of transactions. And you can see just by eyeballing it, clearly the two appear to be related. But we can go further than that. We can actually start to quantify that relationship. So here what we're doing is essentially correlating between the volume of transactions and the response time of those transactions for hundreds of different types of transactions for this application. If you look at the chart down the bottom here, what we're seeing is a number of transactions per minute on the x-axis and response time on the y-axis, and you can clearly see that response time starts to trend up as we increase the volume of transactions. And so we can use that information to see, well, what would happen if I now start to add more transactions into the system? When does it start to fall over? So let's jump to that piece, Scott. What I can do here is to say, let's have a look, for example, at some of these VMs. So in this case here, we're looking at this on an application view now. And again, we have some of these same limitations as we had before, like memory, CPU, and so on. But what we've also got in here are some limits that we've put on the response time of those transactions. So we don't want our login to take more than 3 seconds. We don't want our balance request to take more than 3 seconds. We can see that right now we're below those thresholds for most of them. Login's getting a bit close. But also we can build in some middleware metrics to this. So for example, we saw there was a Java part of the application there. One of the things about Java, we want to make sure it doesn't spend too much time in garbage collection. So again, we can put some limits here and say we don't want to spend any more than 6 seconds per minute, 10% of our time in garbage collection. And we've mined out correlations for all of those things with the application volumes. And now we can use that to model a change. So let's say we're going to add some transactions to this application. We can do that by bringing in what we call a demand template. We're going to add in 2,000 calls per minute, an additional 2,000 calls per minute. And we're going to model this as growth over a period of time, so maybe that happens every week for the next 3 weeks or so. And we can then say, well, what happens if we try to do that? So what this is doing is using those correlations that we've mined out to calculate the impact on the underlying infrastructure of that demand. You can see our first operation there, that has a tick, everything's gone okay, we've got enough resource to deal with that. But we move to our second one, we've got a problem. And we can see that a number, in this case, of the JVMs have been highlighted as having limitations at this point. So I can drill into one of those and see what's happened. And what we're seeing here is that, we can see that our login time has gone up slightly, but it's still underneath our 3-second piece. But our garbage collection has now gone above 7 seconds, and we set a threshold of 6 seconds, so we don't have enough resource to deal with that. Then we can move on and see what happens in the next piece. In this case here, I'm going to see the problem's not restricted to my JVMs. It's right the way through my application. Again, I can drill into any one of these and see that in this case, it's actually my login now is just slightly breaching my 3-second mark. So we can bring in that data, we can do those correlations and use that to then make predictions, model scenarios about what will happen if we make changes in the application. Now the obvious question here is, what can I do to fix that problem? So one of the things we'll do is the JBoss servers, the JVMs were the first ones that had a problem. So let's just go in and model putting in some more JVMs in there, see if we can add in some more JVMs and spread the load across those. So I'm going to drag in a template here that represents one of those JBoss VMs. I'll add in 4 of those. And what we're now saying is we've now got some more resource in there, so that increase in transactions that's coming through can be spread across those JBoss JVMs. We can see that that's fixed my problem here. Now got a green tick in there. But if I move on to my last piece, we can see that we still don't quite have the problem solved because some of these JVMs here still have garbage collection. Now the reason for that is actually we haven't yet modelled proper demand distribution, proper sort of horizontal scaling in that particular JBoss segment. So some of them have higher garbage collection times than others. If we're confident that our application will actually distribute those transactions evenly across those JVMs, we can model that again, distribute the demand. And that's going to then, hopefully, he says with the demo demons, fix that problem. And then we can see that actually, okay, we're good. Now we've got it all done. We're within our headroom for all of our metrics. And with those additional GVMs, we can now actually accommodate that uplift in transaction volumes. So just to summarize, we're mining that data from Genos. We're pulling in that rich combination of the infrastructure and the application information. We're using that to find the relationships. How is the application driving the infrastructure and driving response times? And then we're using those to enable you to model out these complex scenarios. Now that's just scratching the surface of what we can do with Insights Capacity Planner. Scott and I are here all evening, so come and grab us afterwards, get a beer and we can show you some more detail. Thank you.
Hello, everybody. I'm Luis Horna from Solace. I'm senior consultant. Been at Solace for 2.5 years and been in the industry for since the 90s. So mostly in finance. So now what we're going to talk about is about Solace and how we integrate with ITRS. So let's start with next. We'll introduce ourselves first, and then we do the Solace and ITRS integrations with Sol Genius Agent. So let's go next. Let's go fast. All right. What are we now? Solace. We are a messaging company. So messages are very important because everything, like they said, is the network, and if the network goes, nothing flows. So information needs to flow through messages. Whether it is guarantee or reliable, we need the messages. So here as Solace, as a middleware company, we specialize in that. So how do we, in our case, now we integrate with ITRS? For what purpose? So there are different kind of views that customer wants. In this case, what they want is, for example, some under their particular selection of support. For example, they want to know what's happening with their environment and so and so. So that's how we integrate with ITRS. But we go now to the next. So as the technology keeps growing and expanding, so we have expanded through big data, cloud, which now we have our own software site, which is the BMR, which is the virtual messaging that we have. So now we're able to integrate seamlessly through the AWS, through Google, through Microsoft, through all those platforms. So we're very agnostic with whichever platform you want to integrate with. So, and the next messaging generation, such as we can go through, go to the next slide, in this case. So we are very agnostic. In this case, we now want to be open source APIs through that everybody could talk to each other. So we have now, for example, through the IoT, so that if you want to talk to through that protocol, we are able to handle it. So we are able to go through this messaging backbone, and if you are whether you are in the private, public, or conventional messaging, you're able to talk to each other without changing anything, any code or anything. So it's up to our messaging infrastructure to do all the necessary changes for you to just get information. So if somebody's publishing from the IoT and you want to, from the private cloud, wants to subscribe, they get it seamlessly without any kind of recompiling, trying to get in new integration. So it's all seamlessly flows, whether you are web or private, public, or conventional. If you want it, you get it. That's how it should be. So we go to the next. So here we are. So whether you have any taste for any type of language, computer language, whether it's C, C++, Java, JavaScript, Python, Go, here we are. We support all of them. We support also third parties such as Spring, so you get all your templates right on the go. So you have, now we have also, you see MQTT, we have AMQP. So all those protocols seemingly integrate for you. So that's what Solace now tries to emphasize. So regardless of what computer programs or computer language you are into, it's up to the developers. They decide which one they want, and we got for them. So it's the developers' world, and that's how we are also looking into that for that. So we go to the next. So here we are, like I was saying. So if we go into the cloud, here we have the BMR that we can integrate with it. So if you are into the conventional, here we have our own appliance, Solace 3560 in this case. But together, you don't need to change anything. So if you wrote any applications that were working here, now it works also for the BMR. Nothing changes. You just need to point to where you want to go. So that's seamlessly takes care of it. So now, how do we integrate with ITRS? So we use our Sol Genius agent in this case. So we'll go to next. So here we have the big picture. How do the parts work? So in our case, from our Solace part, we have Sol Genius agents. The Sol Genius agents now are going to talk to the net probes through the ITRS gateways and whatever the ITRS consoles tells them what to do in this case. So we go to the next. So we have this, whichever level you want to collect data from, whether it's at the system levels, whether it's CPU, network, or at the VPN level, whether how many VPNs or clients per connections you might have, or subscription events related to topics, queues, any of that categories. So with Sol Genius, you are able to get all those informations into your display. So the system administrators, support can take a look at it, set their own alarms or so. So it's very, very handy and very easy for them to probe the appliance or the BMR in this case to see their environment and whether or not they have the good health in their environment. So that's how they do that. So we go to the next. So here we have now internally how the Sol Genius agent is internally. So we have the Sol Genius agents with our three views for the data, monitor, and the agent service, and how they go through connection through here, through their XML RPRC protocol that they use to the net probe. So these are basically now how we communicate and operate with ITRS. It's very, very simple, nothing like that. So, you know, it's like they say, giving the kiss, keep it simple. Very easy to understand. So and here, at the end, now we have, these are samples of what matrix can you collect through ITRS by probing the Solace architecture. So different metrics, such as you want to see message pools, whether you want to see the client stats or the links that are connected to, or you might want to see the hardware statuses, whether or not the CPU is high, whether the network or so. So, and also the service statuses for the particular appliance or BMR. So this is how we integrate together. Very nice. Whichever, it's up to this support or whoever who is looking into the front end displays to just drive this whole operation. So that's basically it. So we are enabled to work with a third party, in our case with ITRS, and to work perfectly together here. Very nice. Nice.
Great. So we'll keep it moving, and I think we're the last presentation before food and more drinks. So I promise I won't be over my 8.5 minutes. Okay. So thank you for having us here today. So I'm Jared Baker with Symphony, and my colleague Raj Bala, who has a little bit of history here as well. So I'm going to have him do the integration part of the discussion. But the good news here today is I'm not going to spend a ton of time because 13 out of 15 firms that are here today are already Symphony clients. Okay, so that's a great stat. Your job is to convince the other 2 that aren't. So find out who it is, and we'll go from there. But just to give you a little bit of background, so Symphony was started really for 2 reasons. One, to get the financial services community more control and encryption over the messaging that they were doing on these collaboration platforms. So a company called Perzo was really found by these consortium investors, the top banks and asset managers in the world, to really look at that space. People wanted more control over the data that they have, right? They were worried about a vendor potentially gleaning information or looking into chat rooms that were going on in their space and getting some IP that was owned to that bank or asset manager. So from that perspective, that was one reason the company was formed. The other perspective was really just around the efficiency of communication, right? So you think about today, people are inundated with different chat platforms, email, different sets of information. We're embedding a lot of social media concepts to surface information in better ways. So whether it's the @mention, a cash tag for financial services, and hashtags as well, it's really making sense of this information to our users to get people faster responses and more insightful information. So we're about 250 employees globally. All of our development is done in Palo Alto, California. And really the focus is on an investment ecosystem. So while it is about chat, and that's what you probably most hear about Symphony, if you haven't heard about it, in the financial services space, it's about how we plug into the investment ecosystem. So we'll get into that here in a second. So this slide itself, so these are some of our top customers that have used Symphony for really a couple different use cases. We started out as just internal collaboration. So within a bank or asset manager, people are looking for more efficient ways to collaborate. So whether it's from a PM to a trader, across multi-asset teams, getting information that can be then extrapolated so that if a news note comes in about a muni bond, that an equity team could potentially leverage that information and get value out of it. So here you have some of our top testaments from some of our customers. And now, not only is it internal, but it's external as well. So people can communicate with their counterparties, with their vendors, across all of it in a historical manner. So this slide itself, so when people ask me, who are your competitors? There are really 4 different types of competitors, whether it's email. We're taking people out of email and into Symphony. It's persistent, it's multi-dimensional in that you can surface information in better ways. Information is more discoverable, and part of that's using the social media concepts we embed. But the other part of it is just embedding the ecosystem that you have. So whether it's a system like ITRS where you're notifying your employees about a potential outage or specific statistics around the performance of your machines, that can all be done inside of Symphony. Then you have the content side of things. So a lot of people are pumping in their own data, whether it's data that you have here, whether it's content from these specific market data terminals that you want to give people that context to that conversation. So when you're talking about a specific instrument, you want to have the data behind it. You want to have that chart. You want to be able to make that decision so that a user can take action quickly. Then, of course, we're competing with sort of the Microsoft stack, whether it's Skype for Business, Link. Part of the reason we're going up the AV stack is to get people to retire these tools, right? So screen sharing, voice and video calling. So that's a critical part of what Symphony is doing. So it's not just chat, if you take anything away from today. Next slide. So I think for this specific audience, the custom data tagging and feeds is really where it's going to get interesting. So we have a set of 4 APIs. So the most popular API right now is probably the bot API or our RESTful APIs. So think of a bot, ask a question, right? How many shares of this name do I own? What does my system look like here? What is the data that I can glean from asking this question? A popular bot that we have today is a translation bot. So I want to translate another user's language and put it into English. The other one is just a push notification. So again, here, notifying users of specific events that are happening on your machines is probably one of the most popular ways that we're deeply embedding ourselves into the investment ecosystem. Of course, the data is probably the number one thing where people own their own data sets and keys so that no one else, even Symphony itself, can't see what you're doing. That's a critical part of our service and solution.
This is massive. I mean, this is quite a differentiator. If you look at the rest of the competitive landscape out there, we are so differentiated in this area, mainly because even though we host the data in the cloud, the main aspect here is the encryption keys are kept on-prem at the client. All of the data is encrypted at use, at travel, and at rest, so tri-level encryption. The data is contractually and technically owned by the client. So we have zero access to it. You have all the access to it. And most importantly, you can actually mine the data, pick it up, analyze it, and potentially even use products like ITRS to look at that data and see what you can glean from it. Okay, so that's quite unique.
And then the other final point that I'll make here is, so we talked about bot APIs. The embedding agents are quite interesting too. So whether you want to embed the Symphony chat inside of the ITRS tool, or conversely, you could create an app, an ITRS app inside of the Symphony chat platform, so you could get your data right inside of that single container. So we want to provide people a unique reason to come to Symphony, and having this open architecture allows us to do that.
Yeah.
Great.
That's pretty much it. I think the final part was just really on we've taken some steps in terms of enhancements, and one of the major things that we've produced so far this year, the latter end of this year, is we've actually introduced our embedded web widget, which means you don't actually need to have a standalone Symphony client anymore. You don't need to even log in via a browser. You literally can have a standalone JavaScript package which you can embed within your portal. So if you look at like a private wealth type of scenario where you have ultra high net worth clients logging in to your portal, can now have full chat functionality directly to their relationship managers, to do wire transfers, anything that they want. Why are we so comfortable that they can even do wire transfers? Because of the security aspect of what we provide. So, it's quite an interesting area to get into, certainly for us. That's it.
Great. And with that, we're around for the rest of the night if you have any questions. So thank you.